Hello and welcome to part 2 of lesson number 1 in Unit 1 Linear Systems in our grade 10 academic math class. This lesson is graphing linear relations. In this lesson we looked at a review of the 3 methods that we learned to graph in grade 9. The first was graphing using a table of values, which is great. You can use a table of values anytime to graph any equation. The downside is you don't always know what values to input so that you're getting good output you can get on your graph. That's the downside. Good method, solid. Second method we looked at, graphing using intercepts. The benefit of this method is algebraically it's pretty quick to get the values. However, it can be unreliable if you should make a mistake finding one of the intercepts, either the x or the y-intercept. So it's important to find like a confirmation or consolidation point between the between the x and y-intercept laterally, just to sort of prove that you've found the correct values. The last method, and this is the preferred method, is graphing using the slope and y-intercept. Now it just so happens that when you configure a linear relation into the form y equals mx plus b, it just so happens that in the place of the b value, you end up knowing or learning the y-intercept, and in the place of the m value, you end up finding the slope, which, if you recall, slope from grade 9 is going to be the rise over the run. So if we can convert or modify our linear equations into slope y-intercept form, it's actually really straightforward to graph. So we're going to do that now. So here's the equation that we've been given. Y equals negative 2 over 3x plus 4. So this is in slope y-intercept form already, in that we have an isolated y. I'll change up my color here. We have an isolated y just sitting here on the left side. That is what you must look for. You're looking for an isolated y on the left side. After that, the coefficient in front of the x term is your slope, in this case minus 2. And I like to include, if there happens to be a negative, I like to include it as part of the numerator. That is our rise, and this is our run. And then, actually, let me change that color. I think I used blue for the y-intercept over there. So there's our run. And our y-intercept is the constant value sitting here at the end. So how do we go about graphing using slope y-intercept? It's pretty straightforward. We are going to start with the y-intercept, and that's what it says here. If you want to pause and copy this down, it's great. Doing it is even better, but if you want to just hit the pause here and copy it down, now's the time. Okay, back to graphing. Once you have your equation in slope y-intercept form, the first thing you want to put on is the y-intercept. That's the constant value in this equation here that we've just been given. It is plus 4. So I'm going to start by putting plus 4 on the graph here. There's our plus 4. All right. And now from here, we are going to count out the slope. And as I said, slope, as you recall from grade 9, it's going to be rise over run. Now the rise is the numerator, which means from our y-intercept, we are going to do the rise first. So the rise is minus 2, so it's actually not a rise, it's a drop. So we're going to go down from our y-intercept, we go down 2 units, and then we're going to go over the run. And the run, as you recall, is 3. So I'm going to go over from there, 1, 2, 3. So there is the actual next point. The others are just my walking points. And then from there, we can repeat it. From our new point, we go down 2 and over 1, 2, 3. New point. And we can continue to do this as many times as we like. 1, 2, 1, 2, 3. And you can do the same thing in the other direction. 1, 2, 3, up 2. 1, 2, 3, up 2. And there we go. Again, I'm going to try my best to do sort of a straight line through these and see if we can get it. There's actually a straight line function on here, so let's give it a try and see if I can make it work. Kind of, sort of, through all the points a little bit. Yeah, it's pretty good. Okay, so that is graphing using slope y-intercept form. As you can see, manipulating the equation, which we didn't have to do, is kind of the only work. The rest of it is start with your y-intercept and then map out the rise over the run. First doing the rise, either up or down, and then if you're doing that part first, I always like to do it left to right, so as I read. So we're always moving, the run is always from left to right. So let's label our points. This point is 0, 4, and it turns out that our x-intercept also goes through an integer, and that is 6, 0, and now the equation itself y equals, equals negative 2/3 x plus 4. And there you go. That is graphing using slope y-intercept form. That is the preferred method. That'll be the method that I'm working with and emphasizing over the course of the unit. The other two, totally valid. This one's just so much faster. What if you're not given your equation in slope y-intercept form? We just got to flex a little bit of algebra on this, and I've written it over here. The goal is to isolate the y term. I like to do it on the left side of the equation, and then you're going to isolate y. So get the y term alone on the left side by transposing terms away from it, and then isolate y by dividing whatever it's being multiplied by. So let's try a practice one here. Here we have 2x minus 4y minus 8. There is our y and our y term. So we're going to transpose the rest of this stuff over to the other side. So if I'm taking, there's an invisible plus there. If I'm bringing a plus 2x to the other side, it's going to be subtract 2x. This is a minus 8. I'm going to transpose that to the other side. That's now going to be a plus 8. So my next line is going to look like negative 4y equals negative 2x plus 8. And what you'll notice is I put the x term right there near the equal sign, so it more closely resembles y equals mx plus b. Strictly speaking, it doesn't matter, but I like to do it as close as we can to what we recognize. So from here, now we isolate y. We do that by dividing all three terms, or both sides, of the equation by negative 4. On the left side here, we have a y. Negative 2 divided by negative 4. Let's just reduce that and get rid of both of those negatives. So we're going to have 1/2 x, and plus 8 divided by negative 4 will give us negative 2. So it turns out that our m value is going to be 1/2. That's a rise of 1 and a run of 2. And our y-intercept will be negative 2. That would be the point we would put on the graph at the beginning. So that's how we use algebra to rearrange an equation into slope y-intercept form. Let's do it one more time. Example B, 3x plus 6y minus 12 equals 0. So same thing, there is our y term. We're going to transpose the rest of the stuff over to the other side. Let's start with that 3x to the other side. We're going to subtract 3x from both sides. There's our minus 12. We are going to undo that by adding 12 to both sides. So our next step looks like 6y equals negative 3x plus 12. We are now going to divide both sides by 6, or all three terms, I guess, by 6 to isolate y. We have y equals, so let's reduce this, that is negative 1/2 x plus 2. Slope, this time, negative 1/2. So from the y-intercept, we go down 1 over 2, new point, down 1 over 2, new point. And the y-intercept we would start from is at positive 2. So that is your review of how to graph. The homework listed right there at the bottom will help you practice that graphing. Again, if you don't have graph paper at home, even taking lined paper and just drawing some vertical lines on it, sort of make a grid, is very helpful. You can also probably honestly download some graph paper from the internet if you don't have any at home, just some grids on a sheet of paper. So good luck with your homework. We're going to see you in lesson number 2.